Let's look at some of the properties of a periodic function. In this particular case, the periodic function is a sine wave, and the equation of that wave is y equals 2 sine of brackets 3 brackets x minus 45 all plus 1. We're going to list the transformations in the order of operations. So we'll start with the k, which is here. Then we'll look at the b, which is there. Then we'll look at the a, and then we'll finish with the d value. So this k inside the bracket is happening to the x. And you know, anytime something happens to an x, we have to inverse what's happening. So when we see a 3 here, although we would think times by 3, really when it's on the x value, the first thing we want to do is divide by 3. What that means is a compression of 1/3 horizontally, or on x. That 3 tells us do the opposite. Instead of timesing by 3, we divide by 3, or times by 1/3. That'll compress by a factor of 3, or a compression of 1/3 horizontally. Next we'll look at our b value. The b is negative 45. Again, whenever you see something in the brackets with the x, do the opposite. It takes negative 45, so we're going to move the other way. Opposite of negative is positive, so we're going to move right by 45, or 45 degrees. Compression of 1/3 horizontally, move right by 45, that's the x stuff. Now the y stuff, the a value, tells us to take all the equation and times it by 2, and with y we do that. A times by 2 means a stretch. Since it's bigger than 1, we know we're stretching. So we're going to stretch vertically, happens to the y's, by a factor of 2. And lastly, this d value tells us we'll move the whole wave up or down. Since it's a positive 1, we're going to move the whole wave up by 1. Let's look at some different ways to analyze this curve in terms of its properties. Let's record what the values are for d, that's 1. Just looking at this equation, d is 1, a is 2, b is negative 45, and k was 3. That'll help us determine the axis of the curve. The axis of the curve, that is the middle line of this sine wave, is just whatever the d value is. So in this case, the axis of the curve is y equals 1. And the amplitude is also easy. The amplitude is just whatever the a value was. So in this case, the amplitude is just 2. Phase shift a little bit different. Just like we had to reverse it when we were talking about its transformations, we also reverse the b value when we're talking about phase shift. So if it says negative 45, it's really moved 45 to the right, or positive 45. And last but not least, the period. We calculate the period of a sine wave by taking its normal period, 360 degrees, and dividing by whatever the k value is. In this case, the k value is 3, so we divide by 3, and we get 120 degrees. Which makes sense, by the way. Remember back here, this 3 meant a compression of 1/3, and the wave gets 1/3 as big. It only takes 120 degrees when it used to take 360 degrees. And so those are the transformations and properties of that particular sine wave.